We're a 53-year-old family-owned business. We're in job shop manufacturing. We do metal stamping, we do injection molding and insert molding, tool and die. We've used our 3500 HD Max to print injection mold tooling. We currently have 3 of the 3500 HD Max machines in the organization and expect to buy more. It's really helped us tremendously in terms of being able to help our customers do more faster.
I mean, we moved from just a part like this, it has a thin hole, you had a core running through it for the hole, into things like this that are much longer with core pins for holes. Then we actually get into insert molded contacts. We'll load the inserts. We actually use the printed tooling to locate the inserts, and we shoot around them, bringing out just exactly the same process that you would use in a normal production tool. But again, to get an insert molded part in 2 days, you wouldn't even get close with a machined mold, and you wouldn't get this kind of quality. Traditionally, you want a molded part, you buy a metal mold. It'll take 2 to 3 weeks to make it. It'll cost $6,000, $7,000, depending on the part. We were able to take the exact same part and take the manufacturing time for the mold from 2 to 3 weeks to a day, 12 hours. If we get files in the afternoon, we can't ship parts the next day. This particular part, the customer's usual cycle for tooling was 2 to 3 weeks to get a sample. After they released the order for the tooling, it was 2 to 3 weeks. We did 4 passes of this part, 4 tests at the customer in about 6 days, and that included shipping. So the customer doesn't have to make concessions in his design, doesn't have to cut corners, doesn't have to wonder would it really have worked if we had done it this way. They didn't have to make adjustments so that we'd be able to produce them this way. They didn't have to modify the part. These printed molds we clamp with about 4 to 5 tons of pressure, so they don't flash. We don't have to trim parts when we're all done or anything else. We pull them out of the mold and we ship them. The material is very good under compression. But to be able to do a part this thin, this long, even in metal, would have been extremely difficult. Polycarbonate goes in the 550 range. We run LCPs, so we're injecting that at about 635, 640 degrees. We've seen no degradation in the molds at all. They will just take the temperature. Some of the 3D printed molds you see, they're running real low temperature material. It has no physical properties at all. Besides being able to say they were molding, that's all it is. Whereas these are actual production parts. A mold this large, when we put it in our Morgan, we'll clamp that with 8 to 10 tons of pressure. No problem at all, it doesn't mind. You can see this tiny little feature here. That part of the mold was 3D printed in, and we were able to hold that little tiny shape. Because of the support, the wax material, the support, we could heat it up, bring it out. We could get any detail we want. We don't have to try to get in there and high pressure wash them or anything else. We could just melt it out. So any detail we want in these molds, we don't destroy it trying to clean it. Any part that we would want to do, we've been able to do with printed tooling. We could do things in printed tooling that would be very complicated in steel, whether it's inserts or undercuts. That's one thing with the 3D printers. It allows us to create things that you would have just imagined.